Hello and welcome back. So this month went a little off the rails. I had intended to focus on survival mechanics, but got a little sidetracked by rebuilding the terrain system to be entirely GPU driven. I originally was intending to put all of this off for some time, but an update to Godot made the method I was using untenable. I'm not entirely sure what caused this, but looking back at previous versions, I found the current version had a degradation in performance in regards to handing data from the GPU to the CPU. I believe it was some sort of safety put on memory usage, which up until then I had been using unsafely. Regardless of the cause, it only accelerated what I was already going to have to do eventually anyways. Thusly, this devlog will be separated into two parts. The first one will be going over the terrain and what I'm currently doing differently, and the second part will be going over the small amount of work I was able to get done in this month on gameplay. Also something of note, while I wasn't focused on visuals throughout this month, there was a bit of a change up in the color correction LUT files, so the overall color grading will be changing, as well as a small uplift in the foliage density as I go due to the terrain generation improvements. Now, starting with the terrain. The first step was to entirely gut out the original code for the terrain. It was originally two scripts that were working in tandem, the Wandering Terrain Controller and the Page Cache Manager. This was scrapped in favor of a single script which will handle everything regarding this. For now it's called Page Cache Manager, but this will likely be changing as it does a fair bit more now than just handling the page cache. To explain why this is necessary, I will have to go into more detail on how the terrain is generated. In short, the first step is to generate images that are the ground truth of the world. These are images of the stamps that have been placed throughout the world with different passes, allowing for each stamp to contribute multiple layers of data. Which pass is active is controlled via an integer in the global shader parameters. The first is a height map pass, followed by a color map pass, then you have as many data map passes as you want. This lets us do things like have a second height map pass that, for example, lets you put just grass on top of rocks and roofs. The second step is to pass that data into a compute shader, which is constructed via UI elements in the custom editor. This allows you to do pretty much anything with the various layers, constructing layers which are mergers of multiple other layers, generating noise, slope maps, normal maps, etc. This lets me create all the data required for foliage, biomes, and visuals that will be output to the player at runtime. For now, that can only be done one at a time, so the viewport renderer must render one chunk and push that to a series of compute shaders, then execute those before it can go on to the next chunk. Keeping two scripts that both had to have an understanding of that process was introducing all sorts of problems. This resulted in having long pauses waiting to build collisions, resulting in players falling through the terrain. This was because the queue could not be stopped once it was started without significant errors. This is one example of many bugs introduced by this dual script method. Needless to say, this was a mess, and an entire rebuild was in order. Following this, I focused on entirely replacing the CPU-based foliage system with a compute shader method. This was a long journey that resulted in a lot of errors, some of which you can see on screen now. What I ended up on was a multi-step approach. Right now it generates trees by sampling in a grid at the resolution of the foliage with random adjustments to each instance. Then it has a second compute pass that reorders all the instances to the front of their buffers and outputs a count of valid instances, which is fetched by the CPU and used to generate multi-meshes with a valid number of instances. This is somewhat less than ideal, and later on I actually implemented a change to Godot's source code to fix it, but I'll get to that at the end of the devlog. Regardless, this means that each chunk has a multi-mesh for just the foliage in that chunk, and it's fairly efficient. During the foliage pass, I also generated a biome matrix. Each biome is a 2D grid of float values, with each one being the average of that biome in a 32 by 32 meter portion of the larger chunk. These can be sampled from any of the output layers from the base terrain compute shader pass and are used later for all sorts of things like audio, particle effects, AI spawning, etc. The grass was a whole nother can of worms though. For it, I did a secondary system where the grass is made from a chunk that's rendered like a normal chunk but not locked to the 512 by 512 meter grid. It moves in increments of 32 meters, and this keeps the player at the center, so the grass can be generated on the fly just around the player. This also necessitated a modification to the Godot source code, however, allowing for multi-mesh buffer access, but I'll go over that at the end as well. You'll notice while the terrain has a custom UI, I'm still going into a resource file for all of the foliage and the biome layers. While this is used to generate compute shares at the same time as the base terrain pass, I've not yet made UI for them to allow selection of the various options, and honestly this is just because I ran out of time. I wanted to get at least a little bit done on the survival mechanics this month, so I went ahead and left them there. In January I'll be revisiting this when I add in the world scale biome transitions, which are to allow for very large scale differences in flora and fauna. At which point I will also implement the UI for all this, on top of the implementing of the updates to the Godot source code on the indirect multi-mesh command buffers. As for the survival mechanics themselves, I did not get nearly as far as I would like. However, I did implement basic hunger as well as consumable items. To do that, I had to rework a little bit of the inventory and specifically some of the serialization for saving and loading it, but I finally got everything sorted. While the system is nowhere near actually being usable, let me give you a bit of a rundown as to how the survival mechanics will work in the game going forward so you can let me know what you think. I will not be going hardcore with them. I want the world to encourage the act of camping and hunting without absolutely requiring it. At least not without having some toggles in the main menu to turn it off. The reasoning behind this is I do not want a world where the primary focus is to find food as soon as possible and to stock up constantly. Instead, I will be implementing a system similar to how Valheim does it, where if you do not eat, you will have debuffs and you will get buffs for eating good food / special food. But you will not actually die if you do not eat. I may end up changing this, but everything is essentially just theory until the second it hits my testers' hands. As they have proven in the past, they will always tear everything apart immediately. In addition to the food and hunger systems, I went ahead and implemented a backpack system, the idea being that you will not encounter any major issues to traveling with the backpack on, but combat and specifically dashing will be hampered if not outright stopped by carrying everything on your back. And when you go into battle, you should probably drop your backpack on the ground before doing so. Mind you, there will be a marker when you open up your inventory telling you the direction to your backpack. The purpose of this is to force players to make intentional decisions regarding engaging in combat. Run or fight, you should probably decide it pretty early, and if you drop your backpack and decide to run, you're going to want to get it before leaving, or risk going without a backpack for a while. For the world interactions, I finally got AI groups and individuals in after the rebuild of the terrain, with a new species that I'm temporarily calling the antelope. They are herbivores who will only run when engaged, and will provide a solid food source for the player going forward. The AI group systems are still in the early stages and have a fair number of bugs, mostly around them leaving the area and coming back, but so far they are showing lots of promise. The AI director spawns the groups in based on biomes and a multitude of other factors. The groups themselves function based on a tiered system, so AI up close to the player are updating in real time, with character body physics just like the prototype combat AI. When they get farther than 250 meters away, the physics disable and they move automatically along the terrain. At 512 meters and 1024 meters respectively, the update rate decreases again, with the individual AI agents disabling entirely in the distance and just being handled by the parent group at an update rate about once every couple minutes. This system ensures that groups can still do very simple logic and move around the world, even maybe getting into fights with each other, all with the player nowhere nearby, and do so with fairly high performance, hopefully letting the world feel very alive and lived in. And that's pretty much it. Next month I will continue survival mechanics and get some hunting in. While it's definitely not what I intended to do this month, I am very happy with the outcome, and being able to have a clear path forward on the terrain is very comforting. There's still a lot to do, but I know exactly where I'm headed, and I've already laid out the additions to the engine to make it possible. Before I go, a little bit of an explanation as to the changes to the Godot source code that I've done. I've created 3 pull requests, these are updates pending being merged with the master branch of Godot, of which one is just a bug fix, and one is an improvement that has already been merged, and another final improvement that should be merged soon. In chronological order, the bug fix resolved an issue with multi-threaded culling of GPU particles 3D. I encountered the issue, which someone else also encountered around the same time, and I went ahead and implemented a fix for it, which was accepted and merged with Master Branch. For the first of the improvements, the one that has been accepted and merged with Master, I implemented a getter setup for retrieving the buffer RID of the multi-mesh transform buffer. In layman's terms, this is a pointer to the memory of the transform buffer in the multi-mesh. This is super important because this pointer can be directly passed into a compute shader and written to by the compute shader, thus bypassing a lot of CPU work entirely. The second of the improvements, which has not been merged yet, is the implementation of something called indirect draw to multi-meshes. This essentially just means that instead of using the visible instances in the multi-mesh, you can retrieve a command buffer RID, which is a very short buffer of numbers, each one pertaining to a different setting of the multi-mesh, which is then passed to the renderer at the time of drawing, to define how many instances are rendered. Most of the options in the command buffer I handle on the engine side, but the one that's important is actually the second value in the buffer, which is the instance count. This buffer, just like the last one, can be given to and written into by a compute shader. This combined with the last improvement lets the compute shader not only set all the transforms of the multi-mesh, but also tell it how many instances to render. Obviously this is a massive improvement, removing the need to keep count via the CPU or anything like that, and opening the door for really big performance improvements like GPU frustum culling and more. For now I have not implemented it into my project, as right now I still have solid FPS, so long as I don't don't add too many grass layers. But in January I'll be expanding the world, and at that time I'll be using the feature in my project, so it seemed prudent to implement it into the Godot source code, that way it'll be around when I need it. Hopefully all that was at least interesting. There will be links to the pull requests in the description for anyone who's interested. With any luck, the last one will be in the next update of Godot, but we'll see. Thank you all for watching as always, and I hope you all had a good Thanksgiving, and I hope you all have a wonderful month and a Merry Christmas.